Hello everyone and welcome to Java tutorial number 15. Today we're going to be talking about how to make a checkerboard program in two ways, an applet and a standalone Java program. Two things real quick. One, the reason I haven't been posting recently is because I upgraded to Windows 8. As you can clearly see here, I'm in Windows 7. But I upgraded to Windows 8 and Fraps doesn't work in Windows 8 and I had a lot of other problems, and so I ended up installing Windows 7 in a VM and then Fraps still didn't work. I did that like a couple days ago. And then today I tried some other screen recording programs and finally found one that worked well in Windows 7 and that I was able to, I think, get pretty good quality out of, I hope. So anyway, we're back finally, and we're going to be making a lot more tutorials now because we can actually record our screen, which is helpful. And so to kick it off, we're doing a program that makes a checkerboard, like I said. It was based off a question by a subscriber who asked, basically, they're taking a class and they wanted to know how to do this, how would you approach it, what's the logic and the actual syntax itself for making a program with a checkerboard layout. And the checkerboard doesn't have like pieces or anything or rules or anything like that, it's just the checkerboard. And so we're going to do it two ways. We're going to do an applet, and applets were the kind of original idea behind Java, at least to some extent. They are the web-based version of Java. They run inside of websites, like for example if you go to RuneScape, that's an applet, and it runs inside the web browser. You can also download a standalone application from them. But anyway, an applet is pretty well sandboxed, and by that I mean it doesn't have low-level access to the machine. Now, Java in general doesn't really have all that low-level access to the machine. It's just the way Java is built. However, programs have a lot lower level of access than applets do. For example, programs can manipulate files on your hard drive and a lot of things like that, whereas applets are sandboxed by the browser and by the applet runtime. And so programs are a little bit more powerful. However, applets are sometimes easier, and they're also a lot of times more useful if you're just trying to do a small little program test, just trying to get the logic down, or you want to embed it into a website for whatever reason. So we're going to be taking both approaches. The actual logic in them is extremely similar. There might be even some copying and pasting. However, the syntax is different. So, no. I'll activate you later. So anyway, we have in both of these kind of a basic framework for what we're going to do. We imported javax.swing. That's going to be useful for JPanels. Swing and AWT are very similar. However, they meet different areas of work. Swing is more for Windows and, not Windows the OS, but like actual, a window, more for that kind of interface, buttons, things like that, text, and then AWT is more for colors, images, things of that nature. So they really mesh well together for a lot of things, and a lot of times in most GUI applications, you'll often see both being used. And java.applet.wildcard is pulling in our applet class that we're extending. And so real quick, a refresher for what extending means. If you're in Java and you extend something, it means you're building on top of it. So say I make a class called human, and then I extend on it and make a class called boy. Now, what it does is it inherits all the methods and all the automatic setup, the framework for human. However, I can override methods, so I can make a new method that overrides the method in the extended program, in the class we're extending, and as well I can add new methods on top of that. So for example, I might have a class called human that I can call get how tall, and then I have a class called boy that I can call, something else like, get hair color or whatever, if I didn't have that originally in human. So it's kind of building on top of something. So applet's already a basic framework for how applets work. It already has everything implemented kind of for you, and it's already a graphics environment, so you can just hit the ground running with building your graphics application on top of it. We'll talk about a program later, but just real quick, a program instead, you have to make the window and initialize the window and everything first, and so it takes a little bit longer than an applet to get running. However, it's the same logic. So a couple of primary differences between applets and Windows. The first one is that applets are very well sandboxed and don't have low-level system access. The second one is that they have this init method. And this is kind of the equivalent of the public static void main string args you'll see in Java programs. However, the applet init isn't as powerful as you can see. It doesn't accept a string array of args. It also is generally the starting place for your applet, where your applet's going to start and hit the ground running. This is kind of like your main method, but again, a couple small differences, none of which we're going to be really worried about with this program. So inside, let's first start by set layout, new grid layout, rows, columns. And so what this does is we have our integer rows in 8, so we want it to be 8 across, and columns 8, so we want 8 down. Yeah, I got that right. So we set a new grid layout of rows by columns, and that is basically, if you're from HTML, it's kind of like building a table almost. And I know tables don't arrange in tables. However, in Java, it's a very good way to start, especially with a program like this that relies heavily on a grid kind of interface. So we'll use a grid layout to kind of set that up and to create evenly spaced boxes all the way across and all the way down. And what it does is the total number of boxes in this grid layout is rows times columns, basic math. So if you have a table and you have 8 across by 8 down, 8 times 8 is 64, you're going to have 64 boxes. So this grid layout with our current parameters will have 64. However, we can change these. We can put 100 and watch and have fun. The colors themselves, these are the two colors we're going to be switching off or alternating between during the program. The reason we do this is so we can quickly change our color from using black to say green or whatever, and I'll show you that later. So we set our layout, and let's define a color called temp. And this color temp is what we're going to be constantly switching off between and setting panels to be that and whatever. So we're going to do a for loop for int I equals 0, I is smaller than rows, yeah, and I++. And so what this does is it says we're going to start an int at 0, and we're going to run this. Every time we run it, we're going to add 1 to I, and once we hit the size of rows, we're going to stop running. The reason we don't do less than or equal to is because we're starting at 0, so rows is 8, so 0, 1, 2, 3, 4, 5, 6, 7, that's 8 runs. So that's perfect. And then inside, a little bit later, we're going to nest another for loop. So this iterates through the rows, and then we want to iterate through the columns. However, before we iterate through the columns, we're going to want to set the color to be the starting color. And this is a little bit hard to explain. However, just imagine it as you have your grid, and on the first row, you start with red, and you go red, black, red, black, red, black, red, black. Then the next row, you wouldn't want to start with red again, because if you kept doing red on every row, you'd get like these bars of red, bars of black. On the next row, you want to start with black, so you have black, red, black, black, red, black, red, so that they're offset. And so we'll explain that a little bit in a minute when we actually see the program running, and I'll point to where I'm talking about. For now, just realize we have to switch off between them at the start of the row. And so this runs every row, so it's a perfect time to switch off between them. So if I mod 2 is equal to 0, remember the mod operator is basically saying divide I by 2 and give me the remainder. So basically mod 2, if mod 2 equals 1, equals 0, then it's even. 8 mod 2 is 0, 6 mod 2 is 0. If I mod 2 is equal to 1, then it's odd. So 7 mod 2 equals 1, 9 mod 2 equals 1, 11 mod 2 equals 1, 13 mod 2 equals 1, etc. So in here we want to switch temp to call, let's start with call 1. And then else if it's odd. So if it's even, do this. If it's odd, then set temp equal to call 2. You could also do else if I mod 2 is equal to 1. Either one works. That's just a little bit less typing. Now we're going to do our second for loop. This for loop is going to go through the columns and set up a JPanel colored box inside of there. So for int j equals 0. We can't use I because we already used I up here, and when you have nested for loops you can't use the same variable twice. J is less than columns, j++. And actually, fun fact, the reason they use I in for loops is because with summation notation and sigma notation and things like that in Algebra 2, they use I to be the iteration number. So just fun fact of the day. Equals 0, j smaller than columns, j++. So here we're going 1, 2, 3, 4, 5, 6, 7 for our current parameters. 0, 1, 2, 3, 4, 5, 6, 7. That's 8. So that's why we have less than, not less than equal, and less than or equal to. And so this for loop is going to iterate through the column. So we go row, column. So each time this inner loop runs, we're filling one box. If we had a three-dimensional thing, which would be fairly hard to do, we'd have 3 nested for loops. There's other ways to do it. That's probably just the easiest and most logical, straightforward way. So in jPanel, panel equals new jPanel. That's something you'll find about Java if you haven't already. It's very redundant for a lot of object initializations. Honestly, if you just put jPanel panel equals new, semicolon, obviously Java won't accept that. However, Java could easily be made to accept that if this jPanel doesn't need any parameters, so it could just be kind of a shortcut, just like I++, and short for I equals I plus 1 or I plus equals 1. You know, but I don't design Java, so I don't have in that, but I think that'd be a cool feature. Anyway, panel.setBackground call, or sorry, temp. And so the panel, each panel is one of the squares on the checkerboard. We're using panels as kind of like, you know, window panes or anything like that. They're just little panels that each contain something, and we're adding those to a grid layout. We haven't added them yet. We want to set the background to the color temp, and then we want to do if temp.equals call 1. Then we'll want to do something else. We'll want to do something else. So the purpose for this is we want to, if we just use black, we want to use red. If we just use red, we want to use black. We want to switch between the colors every time this for loop runs, or else we'll just get a straight, it'll look like a straight bar across of a certain color. So we want to alternate between them. So we'd have, if temp.equals call 1, then we want temp to be equal to call 2. The reason we do dot equals instead of the two equal signs is because dot equals is a more advanced, they call it a comparator operator. It's a nice phrase. And basically the idea behind it is that if I say if quote 1 end quote equals quote 1 end quote, it'll return false. And it's like, what? Why is it returning false? What is it doing? The reason is because since they're not primitive Java data types, int, double, char, short, long, byte, boolean, whatever. And actually booleans can use a single equal sign in some cases. But anyhow, since they're not primitive data types, they're actually pointers to an object in memory, and so it's comparing the two pointers. They both point to objects that look the same, but the objects are in different places. They're two separate objects, so it says they're not true because they're not the same object. Dot equals, however, just compares like a checksum or something of that nature between the two objects, and says whether both objects look identical. And so that's why we use dot equals. It's a little bit more powerful, and it's used for objects. Else temp equals call 1. And so if we run this right now, you'll see nothing happens. Nothing at all exciting happens. The reason, and then this yells at me. However, what we need to do is we need to add this jPanel. It's not automatically added, so we can just use the add method to add the panel. Now, in the program, we'll be adding it to an actual JFrame. However, here, Applet, extending Applet already gives it a certain inherent graphics ability, so we can just call the add method directly on Applet because we're extending it. So if we run that, you'll see this nice little checkerboard here, and it doesn't yell at us anymore, which is nice. You'll see it just flashes like crazy. Hope no one's epileptic. And basically, you get this window that scales very well, aside from the flashing, and it also is very useful for resizing the applet when you have it standalone. However, on a website, that's a little bit harder to do, and users generally aren't going to be resizing very much, so something to keep in mind. So let's just test our parameters to make sure we're not just fooling ourselves here somehow with magic numbers. So let's put in 16 by 16 and run it. And there you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, it counts up to 16, cool. Let me go back to 8 by 8 and explain, actually let me do 4 by 4 and explain the logic that I was talking about earlier a little bit better now that we have an image. So there's our boxes, and so if we start with black and then we do red, black, red, then on the next line we don't want to start with black again, we want to start with red. So black, red, black, and then black, red, black, red, red, black, red, black. So what you want is you want every row, every row across as you go down, row, 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 you want them to alternate colors, and you want every column as you go across to alternate colors. So color, 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 color. Now, just to show how kind of adaptable this is, let's change black to green and red to black. That was kind of pointless, but you'll see we now have, I personally like red and black better, it's kind of more traditional, but what if we did white and black? This one looks kind of lame, I must admit. But it looks like that. It kind of looks like it runs off the sides of the window, to be honest, because it's the same as the background applet color. But anyway, that's how you make it into an applet, and that's kind of the program logic you're going to be looking at. Let me set this back to how we had it originally. And run it. Yep, we're good. And this source code will be in the description below. There will be two of them in the checker applet.java and checker program.java will be in a zip folder in the description below. It'll be a MediaFire download, so just FYI. However, or actually no, I'm going to start downloads from theopeneffect.com. So it'll be a theopeneffect.com link. So anyway, let's do the same logic in a program. Now the actual logic here is extremely similar. However, the actual setup behind is a little bit different. So let's transition over to that one. That one involves actually setting up your own graphics environment, which is not hard, it just is a couple extra steps. So we have our imports in order, we have all of these just here, everything's good to go. And our main class is again where programs are going to start. It's basically the applet, the program equivalent of the init method, but there are some main differences. So we're going to create a JFrame, and we'll just call it checkerboard. I can't type today. Equals new JFrame. And checkerboard is going to be kind of our window. So we're going to set the size. Let's do 800 by 800. Checkerboard dot set size 800 by 800. So I like 800 by 800. It's a good size for the screen. However, you can set it to whatever you want and it'll still work. If you set it really small, it might glitch out on you though. So checkerboard dot set title checkerboard. And you see we have a lot more control here. Actually, let's make that one word. We have a lot more control here. We're setting the title, we're setting the size. If you'll go back to the applet real quick here, it just says applet, and at the top it says applet view, and it'll say viewer checker applet.class. Here we can actually set the name of the class. So we can set it to be checker program. We can set the size that we want the window to be. And so we have more control, more customization, and we would have... Why is my networking not working? Oh, well, whatever, it doesn't really matter. And we also have this kind of control over lower level system resources, which we don't need here, but if we need to do file reading and writing or whatever. So anyway, hello Nemesis. Checkerboard.set title. So after we set our title, we're going to want to make a container. And a container is basically just like it sounds. It's something that holds a bunch of things together. It's something that is kind of just there to hold a bunch of elements of something. In this case, we're holding a bunch of graphical elements. And we're going to make it of the type checkerboard.getContentPane. So it's going to be a content pane, a container, and then we're going to set the layout to grid layout. So again, a little bit more confusing here. Container, container, pane equals new equals, sorry, checker, can't type today, board dot get content pane. Just like that. And so now we have this container that's going to hold stuff. And we'll set pane dot set layout new layout rows columns. And just like that, we now have this layout nicely set with a grid layout, and so a little bit more convoluted way, but these two lines accomplish the same as this one line here. We'll be going back and forth to compare them. This is kind of the equivalent of this, to be honest. Extending applet gives us all these things kind of built in, or we don't need them. So this stuff is not needed because of this. This is the equivalent of here. And then the rest will be pretty much the same logic, but we'll have, instead of, add panel, it'll be pane.add, blah, blah, blah. Pane.add panel. So, but the rest of it's going to be extremely similar logic. So basically, we'll want to do our for loops again. And in fact, I'm just going to paste this in and edit it so it works. So color temp, to there. And paste this in right there. And then we're going to make a couple small changes. So instead of do pane.add panel, we're also going to do, actually that's it. That's all we have to do, I think. And so if you run this, you'll see nothing exciting happens. In fact, a window doesn't even open up. How lame is that? So outside of this first for loop, so once we're done with everything, so this for loop's run 64 times, this for loop's run 8 times, because this runs 8 times for every time this runs. Outside of that, once we've added everything to our checkerboard, to set it to visible. So checkerboard.set visible true. And then we'll start that program up. And boom, there we have it. There's a standalone program that makes our checkerboard. So, just to alleviate any smoke and mirrors, green, and let's do 200 by 200. I love doing this one. I'm running this in a VM too, so it's like crazy slow. And ta-da, it looks. The reason I like doing this one is because you'll see it has this border here, and it can have this border for 2 reasons. One, it's not done filling, which may be the case, or 2, it can't evenly divide the pixels into 200, so it has some left over. For example, say since this is 200 blocks across, say we stretch this a little bit, see it stretches to accommodate it, and that's what's going on here. If we there we go, right there. The thing is, if it has 400 pixels, each one will be 2 pixels. But if it has 500 pixels, each one will still be 2 pixels, and you'll have 100 pixels left over because they can't evenly go into 200. So kind of these borders are like the remainder that couldn't be evenly divided between each one of these. Java doesn't divide lower than a pixel in this instance. So that's why you get that. If we stretch this a little bit further, there we go. Oop, there we go, and there. So what you'd do if this was a professional application is you'd actually do the math for how wide you want your window to be to accommodate all of these, and you've got to factor in things like, borders and things of that nature. So anyway, that's how you do that, and let me change this to black. It looks really cool on black. Black and red, it looks just like something bad happened when it overloads. But anyway, that's how to make it as a program. As you can see, it's the same logic, and we just pasted the logic in from here and changed one line. However, it's the setup that's different. It's this creating the JFrame, setting its size, setting the title, and creating a container and setting that container to a content pane layout, and then setting a new grid layout. It's a little bit more work, a couple more lines than your applet program. However, it's more powerful. You can make a standalone jar out of it. You can do a lot of cool stuff like that. So program is probably the preferred option for most avenues. However, if your main point is just to get the actual program logic in, applet might be the way to go. So thank you for joining me. This is Java tutorial number 15. I don't know what 16 is going to be. If anyone has any suggestions, I'd be more than happy to take them. We might be doing something more with graphics, or we might be kind of doing a aside into the ACM graphics library, but we'll figure it out. So thank you for joining me, and I will see you next time.